Hi, this is Mr. Max, and today I'm looking at applications of differentiation. So I'm going to look at a few questions and also how you should approach them. All right, so here we have a diagram shows a cylinder and the height of h and a base radius of r, as you can see, inscribed inside a cone, and the height of the cone is 24 centimeters and the base radius of the cone is 10 centimeters. All right, so I can see some sort of um, you can call them similar triangles. So I'll perhaps say this is triangle ABC and the other one will be triangle ADE. Okay, so that will be my D. So I can see similar triangles there. Triangle, if you look at that, so if I had to draw that quickly, it will look something like this. Okay, so I have my 10 here, I have my R here, and well, this whole distance here will be 24. Okay, so for this part, the distance, maybe I should bring in a different color so you can see where I'm going with that. So this distance here all the way up to there will therefore be 24 minus h. Okay, let's just have that nice and easy so you can get to understand where I'm going with that. So this distance here will be 24 minus h. That will be from here to there. And the whole one from there will be 24. Okay, so I have similar triangles, so therefore I can have like 10 over r, okay, the long one of that is equal to 24 over 24 minus h. Okay, so your objective there is to write that in terms of h. So from here you can have cross multiplication. So that could be 10, and then you have 24 minus h is equal to 24r. Okay, should be able to multiply these out. So it's 240 minus 10h is equal to 24r. In fact, there's also another way. The idea here is for you to make h the subject of the formula. Okay, you can. So I'll have minus 10h is equal to 24r minus 240, and then I'm going to divide throughout by negative 10. So when I divide by negative 10, I'm going to have 240 positive minus 24r, all of this divided by 10, okay? Which means this becomes then h equals to 24, because 10 goes in there, minus 2.4r. Now 2.4r can also be written as 12 over 5. Okay, but since we are there now we know what the height is. So I have now the height in terms of r. So now what I'm looking for, we look to see whether we can get the h in terms of r, as I did, and then we are supposed to show that the volume of the cylinder. All right, so the volume of the cylinder, well, let us just get one thing straight. You know that the volume of cylinder is pi r squared times h. So the volume is going to be pi, and our radius r squared, and our h now is replaced with 24 minus 2.4r. Well, you can definitely end there, but we want it to look similar like what we're given in the question with the pi outside. So I'm going to distribute the r over, so that means I'm going to multiply by r. So the volume therefore will be pi outside, then is 24 r squared minus this 2.4 r cubed. Okay, so another way that you can write 2.4, if you grab your calculator, you can also write it as 12 over 5. So definitely you can also decide that this here is 12 over 5. Well, it's the same thing. So if you end here, they are also perfectly okay. Okay, so that's what we needed to prove there for that question. So if we go back, it says you are supposed to express the volume of the cylinder. Well, you're supposed to get to this, but the first thing that you needed to do is you needed to express H in terms of R. Then once you have expressed H in terms of R, which is this value here, then you substitute that value into your formula for H when you find the volume of a cylinder. So definitely you need to know your work on ordinary level before you look at the calculus course. Okay, so let me just write that in there. So the volume is pi, and it's 2.4, or let's say it's 24, not 2.4. So it's 24 r squared minus, well, they say 12 over 5, doesn't matter, r cubed. So they say, given that r varies, we're supposed to find the maximum volume of the cylinder. So we can find the maximum volume of the cylinder when we differentiate dv, dr, and let that equal to 0, finding the first derivative. Okay. Right, so before I do that, I just want to clear this up nicely. So I have 24 pi r squared minus, well, we can have this as even my 2.4 pi r cubed. It's a little bit better. So now when I differentiate dv dr, you're going to have 2 times 24, that's 48 pi r, minus, now you can grab your calculator and you can multiply obviously the 3 times, so just go to the calculator. So you're going to say 2.4 times 3, so it's 2.4 multiplied by 3. Okay, so that gives you 7.2, or 36 over 5, so I'll have 36 over 5, all right, pi r squared. All of this should equal to 0. So we are supposed to find the maximum volume. So before we can find the maximum volume, that means we're going to substitute our R. We need to calculate our R, and then we substitute it into this formula. We're already told that it's a maximum, so no need for us to check or determine whether it's a maximum. Okay, so this then brings me to, well, you have minus 36 over 5 pi r squared is equal to negative 48 pi r. Well, this is just simple algebra. So from here, you should be able to do a few things. Okay, so first of all, I'm going to multiply this by its inverse. Okay, and what I do there, I'm also going to do on this side, minus 36 upon 5. All right, so that leaves me with pi r squared. So a negative and a negative gives you a positive value. So if you do multiply that out, again, you can grab your calculator. So you'll have 48. Then you multiply that by 36 upon 5. Okay, that gives you definitely some value. So 48 times 36 over 5. Okay, you get an answer there. And then what you do after that, I just want to correct a little bit of something here. I just had my reciprocal wrongly here, so it should be the other way around. It should be times 5 over 36. So times negative 5 over 36. Then I should be on the clear. So it's going to be 48 times 5 divided by 36. Well, you should get on this side, you should get nothing but 20 over 3. All right, so that's pi r. Well, so the next thing you can do, okay, you can just divide by pi r, so that you are left with r. Then our r will equal to nothing but 20 upon 3. That is what r is equal to, or you can go ahead and say 6 2/3. Okay, now that we know what the value of r is, we need to determine the maximum volume. So in order for us to determine the maximum volume, so to find the maximum volume, we are going to substitute this value of r into our volume formula. which if you recall, it was 24 pi square minus 2.4, that was 2.4 pi, and it was raised to the power of 3. So just go back there, okay, our volume formula. Well, I'm using this one here, 24, anyone that you use, okay, you should get to your answer, right? So what is our maximum volume? Well, substituting in the value that we have. So if we substitute here 20 over 3, 20 over 3, well, you should end up with perhaps 355 and 5 over 9 pi. Well, this is cubic centimeter, or you can even get things like 1117, give or take, cubic centimeter. So that is the volume, the maximum volume that we're looking for, okay, in order for us to find it. So it's just simply a matter of algebra, and once you are used to that, then you should be fine. Okay, so just have a look again at the question so that you know what is it that you need to do. All right, you need to be able to express h in terms of r. That means as you have the height here, you need to express it in terms of r, and you also needed to see the similar triangles. Okay, for example, what I mean by that, I just quickly have to go back. I see that triangle ABC is similar to triangle ADE. Okay, and then I use that concept in order for me to find missing values, or expressing h, that means make h the subunit formula and write it in terms of r. And once you have your value of h, now you can find the volume of the cylinder. As you know, it's pi r square h, and then you substitute for h what you have done in the previous section, and then you arrive at what was required. And then when they say, given that r varies and find the maximum volume, they don't say you must determine, you find the maximum volume. So dv dr should equal to 0, and you find the value of r, substitute it into the volume. So because you're looking for the maximum volume, and once you substitute it into the maximum volume, and you therefore have your volume.